Hello, Shubham sir.
Yes,
Yeah, I
yes,
mean, say, uh, could you just tell us exactly what was the motivation before, I mean,
yeah,
behind this
yes,
particular thing?
yes. So, yeah, Anushka, you can start, and we'll slowly people are joining.
Okay,
Okay.
fine.
Okay, thank you, sir. So, very good evening to everyone. Welcome to the first seminar of the PySquare seminars. So, this is a peer to peer learning platform where we provide you an opportunity to learn mathematics from your peers, to deepen your knowledge about mathematics, enrich yourself about mathematics, and really, like the subject, not only the typical curriculum thing, but here we provide you a platform to go beyond your curriculum and enjoy mathematics. So this is a platform that will actually provide you to enjoy the subject. So now I'm going to so right now I'm going to share some of the brief objectives of the PySquare seminar. So firstly, this seminar is going to be a very interactive seminar where you will be learning from your peers, and we will go beyond the beyond our curriculum, not only what is there in our BS degree syllabus, but we can learn a lot from our peers as well, which might be not very very cliche about our syllabus, but beyond that. And you can interact with our instructors and with your peers. So the frequency of the seminar is going to be like, right now we are just starting the seminar, so we are aiming to conduct it weekly for 40 to 45 minutes, so now let me introduce you to our members of the core team members. I'm Anushka Roy. The Anand, please, can you please switch on your video? Like, is it possible?
Yeah, just a second, okay.
Yeah, thank you. So this is Anand. Diptanshu is there. Anand, Diptanshu, it's me, Anushka Rai, and Shubham sir, the main head of this entire thing, who planned this entire thing to create a very interactive program with everyone among this seminar. So also there are other members. There is Aryan. Aryan, are you there? Or I think he got disconnected due to some internet connectivity. It's fine. So right now I would like to request Shubham sir to say a few words.
Okay. Thanks, Anushka. Thanks to the four-member team. So we have, yeah, Anant is there,
Yeah.
yeah, Aryan is there, and Dipanshu is there. Okay. So uh, thanks and good evening to everyone. Okay. So as the Pi Square seminars, is a initiative, it is a kind of collaborative learning, sharing knowledge and sharing knowledge in mathematics. And it's, I take a great pride in launching this. I'm very excited to launching this. This is a platform actually, and here you can know you can explore mathematics concept, and enhance their presentation skills. So here, what is the main idea is that this platform is actually I have created for purposely to not only learning purpose, and not only the learning purpose, it is actually created for, you will know how to present also. Once this is you have a uh, suppose you want to present something, so you have some stage fright. So even how to create some slides for a presentation, so this all knowledge would be, will share, uh, means here our core team member will, will help you to create slides, how you will present. So this everything is going to be here, and this is one part of, creating slides, or or other things, or how to present, how you'll fight, how you'll remove your stage fright. This all is one thing. And the second part is, once a student will start presenting something, or maybe whatever the content he will deliver, that may be already, it may be known for you, but it could be a kind of revising also, and maybe it could be a new for you. So this is for the student side only, but we will try to, arrange some different not only the student side, will try to some PhD scholar, maybe some profs will also be here. Maybe in later presentation they will be also invited. This is the first time, for launching this pi square seminar series. And professors would be give the talk here, PhD scholars would be will give the talk here. Maybe they will also be here. Maybe some PhD scholar giving a different, maybe fractal idea, or somebody I have seen, when I spread out the G form, somebody was saying that I want to present on fractal or something, somewhere some different topic. Somebody says in the statistics or probability also. Everything we are going to be here. This is a platform. You can join with us and can share your knowledge, can present, and uh, this is how it will go. Okay, so this is the pi square. Uh, and now this is all about the pi square. And I will now say to Anushka, do you want to say something now? That's all from my side. Thanks everyone for joining here. Okay.
Thank you, sir. Thank you so much. So, right, so for the first day of the Pi Square seminar talk, Kiran will be presenting the first talk of the seminar. He is a foundation student of our BS degree. So, Kiran, please unmute
Hello all.
yourself.
Good evening.
Good
Uh,
evening.
may I know, may I know at max how much time will I be allowed to present and for a Q&A?
It's about 40 to 45 minutes, I guess.
Yes, Kiran.
For
Yeah,
You, Kiran, you can first, turn on your camera. And then generally this talk would be, this is 30, 40 minute, 45 minute, this kind of, this much time.
while presenting, I would like to be off camera.
Sorry, is there any issue you think? Yeah, Kiran?
actually, he
Uh,
is saying that while presentation, he has to turn off his camera. That's fine, I guess, because he will be sharing screen and we
Yeah,
can
yeah.
hear him, so it's fine. Okay,
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 okay.
okay. So, sir, shall we start
Uh,
with Kiran?
Yes.
Okay. So, Kiran, now you can start your presentation. Thank you. Thank you,
yeah,
everyone.
thank you. Hope my screen is visible.
Yes,
Yes,
yes. It's
visible.
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 Shall I start or is there
One
anyone
minute. Just a
like
minute.
to join?
Just a minute. I would request everyone to please turn off your mics while Kiran will be speaking. All of your questions will be attended later at the Q&A session, and you can by the time you can also jot down your questions somewhere else or even in the chat box itself. We will refer to the chat box shortly. But please don't turn on your mic, because it will be a mess back then. Thank you. Yeah, yes, Kiran. Now you can start off.
Shall I start or is there anyone yet to join?
No, no, you can start. You can start.
Okay. Hello all. Good evening. Welcome to this session of mathematics. Is my screen clear?
Yeah, your screen is visible.
Okay. Um, Welcome to the world of mathematics. Yes, we are already in this world, but uh, mm, with my session, I will develop the mathematical intuitions a bit more, so you will be feeling to enter into some other world. So first of all, talking about mathematics, what is mathematics about? Would anyone like to answer? I would like to make it interactive. Hello.
What was the question?
Would anyone like to answer for the question, what is mathematics about? Think,
So
how do we explain mathematics, or how do we define mathematics? Would anyone?
mathematics is basically about numbers.
About numbers, I'm not asking what is mathematics all about. We can say, one may say mathematics is the science and study of numerical figures, data structures, algorithms, statistics, information theory, etc. And some people may say mathematics deals with logical evaluation and quantitative calculation. I'm not asking about what mathematics deals with or what is mathematics about. And I'm not even asking to explain about mathematics. I'm asking for a concise definition for mathematics. Would anyone like to go about it? Okay,
So, Kiran, if no one is answering, you can answer and move ahead.
okay,
Also,
okay.
yeah.
Um, why do we have to talk or learn about mathematics? Our everyday activities are linked with mathematics. So mathematics is everywhere. Mathematics is just a different dimension of science, and science is incomplete without mathematics. So it's from starting everywhere, and mathematics is embedded within science. So we have to learn about mathematics. When we learn about science, it is everywhere. We use mathematics in every daily activity. So, going forward, instead of explaining it or talking about what mathematics deals with, uh, if we want a concise, exhaustive definition for mathematics, how do we define mathematics? Now, I'm gonna go about it. I will say mathematics is the science of unknown. This definition, I think it's the perfect one to define mathematics, but it may seem peculiar for some of the people because this word science is taken from a Latin word scientia, meaning knowledge. And I'm saying science of unknown. If I go about it in this way, it may seem like unknown knowledge. Knowledge is something that is new. If I say unknown knowledge, that won't make any sense. Unknown known, right? So instead of saying unknown science, we can uh, coin a special term, mathematics. And for some people it may seem awkward because people may interpret maths and science as different subjects. But if you ask me, I say just we just learn two forms of knowledge. One is literature and one is science. Even social is part of science, right? So what unknown we are talking about? It's not the usual unknown we interpret. This term unknown is a bit more involved and a bit twisted one. Unknown means we may be given some properties of a geometrical figure, and we may be asking about one of the side or internal uh, angle x, or that way uh, we may be given with some principles or some observations, and we may be asked to find some unknown value. Then we apply some mathematical properties, logics, and do some analysis. That is what mathematics is all about. Mathematics is about logic, proof, analysis, statistics, and it may so go on, so on. So this is how we can define mathematics. I hope it is clear. So let's take a case study before I get into the actual topic. You can see a figure here. A lady is standing on a ladder that is inclined onto a pole. Uh, she is an electrician. She is supposed to repair this electric fault on a pole, and this is of height 1.5 meters. And from this point to this point, this length is 1.3 meters, as it's saying here. She is on to do this repair work, right? Now, our question is, what should be the length of the ladder that she should use? This ladder, which is inclined to an angle of 60 degrees to the horizontal, would enable her to reach the required position. Yeah, she's already reached, but let's say suppose she's not reached to this point. We are given with some observations, right? This length from this point to the end of the pole is 1.3 meters, and the height of the pole is 5 meters. So this length till this point will be 5 minus 1.3 meters. So it's like 3.7 meters. And another observation we are given with is the angle of inclination. This is 60 degrees. So we have these observations. So how do we find this ladder length? That is our question. And we have another question here. How far from the foot of the pole should she place the foot of the ladder? How do we go about it?
By
We can,
trigonometry we can use.
yeah, we can use trigonometry. From these kind of daily life situations or engineering practices or some way or the other, even in astronomy, trigonometry comes into play. It becomes very vital. It is one of the most essential tool. We have observed a right angle triangle here, right? So this right angle triangle is special among other form of triangles. Uh, Whether it's equilateral triangle, isosceles, or some other. Right angle triangle is the special one. So it has some predefined properties. Based on these properties, a special chapter emerges because one of the side hypotenuse is always larger than the other two, except one of the angle is 90 degrees or 0 degrees, where by base and hypotenuse embeds, they will coincide. That's the other thing, by the way. And we have Pythagorean theorem, and we have some relations between these angles and sides. Based on these properties, trigonometry comes into play and becomes essential in these kind of case studies. So I think I have developed some intuition about trigonometry. So getting into the actual part, this is one of my favorite chapter in mathematics. Coming into trigonometry, we have our overview. First of all, we'll go through some bit of history and then trigonometric ratios, Pythagorean theorem, complementary angles, standard ratios table, trigonometric identities. We'll have proofs as well as the theorems as well. Let back to 476 AD to 529 AD, we have our hero here, Aryabhatta. First, introduce the trigonometric concept. He used the idea of sine in his book Aryabhatiyam in AD 500. He used the word ardhaja for the half chord, which was shortened to ja. When this book, Aryabhatiyam, written by Aryabhatta, was translated into Arabic, the word jiva was written as it is. Later, after some translations, when this word jiva is translated into Latin, the word sinus, also used as sine, became common in mathematical texts throughout Europe. So this idea of sine comes from India no origin only. For the first time, an English professor of astronomy, Edmund Gunter, used the abbreviated notion of sine as this form sine. Um, Similarly, other trigonometric ratios also got abbreviated. We'll look into it later on. Coming into the definitions of trigonometry, the word trigonometry is derived from the Greek words tri, gon, and metron respectively, meaning as tri means three, is it's a simple literally. Gon means sides. Some textbooks refer gon as angles. By the way, trigonometry deals with the relationships of angles and sides of a triangle. And metron means measure. We know it. Trigonometry is the study of relationships between the sides and angles of a triangle. This is what trigonometry is all about. Okay. So getting into trigonometric ratios, consider a right angle triangle. So right angle at B, we have a base, altitude and hypotenuse. Here angle A is acute angle. This angle A is what we are considering for these ratios. Now the side opposite to this angle A becomes the opposite side to this A, and the adjacent side to it, the altitude, becomes its adjacent side, and hypotenuse is as usual. So if we want to find sine of angle A, cosine of angle A, and tangent of angle A, we have to do these ratios. For sine A, simply we have to take the ratio of the opposite side of A and hypotenuse. Sin A is equal to opposite side by hypotenuse, which is in this case BC by AC, and cos A is adjacent by hypotenuse. Here it is AB by AC. And then tangent is just the ratio of these two, sine and cos. If we take the ratios, these two hypotenuse cancel, and tan A is just opposite by adjacent side. Tan A is equal to opposite BC by adjacent AB, base by altitude. And we have some other trigonometric ratios like cosecant, secant, and cot, which are just inverses of these. Um, these are not important to put them here. We want to find the cosecant of A, we just take the inverse of this. It becomes hypotenuse by opposite, and then the secant becomes hypotenuse by adjacent. Cot cot A becomes adjacent by opposite. That is it. Okay, before getting into more details of trigonometric principles, I would like to uh, explain about Pythagorean theorem. We consider a square as follows. You can see here in this figure, each side of this square is of length a plus b. We have four right angle triangles internally and a square of side c. So, as we know, the area of a right angle triangle is half of base into height. So the area of each internal right angle triangle becomes of AB. So if we can find the area of this square in two different methods. We just take a plus b whole square, side square, the area of the outer square, which is equal to the sum of areas of these triangles and the area of this inner square, which is equal to c square, area of this square, plus 4 times area of each triangle. We get a square plus b square plus 2ab using the plus b whole square identity. And on the right side, we get c square plus 2ab. Cancelling 2ab on both sides, we get a square plus b square is equal to c square. Consider this particular right angle triangle below. Here B is the base, A is the height, and C is the hypotenuse. So we get base square plus height square is equal to hypotenuse square. Or you may say side square plus height square is equal to hypotenuse square. This is how we get a Pythagorean theorem. This is how we can derive it. I tried to make it simple enough. I hope it is clear. Okay, let's talk about complementary angles. Complementary means the sum of two angles is 90 degrees. That's it. Consider a triangle, taken the same triangle as follows. We are considering this base angle. Now, sine theta, as we know, it is opposite by hypotenuse, is equal to cos of 90 minus theta. Let's analyze how it is happening. If this particular angle is theta, then this becomes 90 minus theta. We can go about it in two different ways. Sum of all internal angles is 180 degrees. So in that way, we can find this angle as 90 minus theta. Or the other way, we can extend this, and we know that sum of two internal angles is equal to the external angle, this sum of two internal opposite angles. In that way, we get this particular angle A as 90 minus theta. I haven't mentioned it here. It's difficult to edit mathematics in PPT. So consider this angle sine theta becomes opposite by hypotenuse, altitude by hypotenuse. And if we take this angle, uh, opposite side to this angle theta becomes adjacent side to angle A. So sine theta becomes equal to cos of this angle, cos of 90 minus theta. Sine C is equal to cos A because the opposite side is becoming adjacent side. So that is how we get sine theta is equal to cos 90 minus theta. Similarly, if we consider cos theta, in this case, adjacent side for theta is becoming opposite side for 90 minus theta. Or the other way, adjacent side to angle C is becoming opposite side to angle A. In that way, we get cos theta is equal to sine 90 minus theta. Um, Similarly, we get these values with the same intuition. Nothing special. Tan theta is equal to cot 90 minus theta. Cot theta is equal to tan of 90 minus theta. Secant theta is equal to cosecant of 90 minus theta. Cosecant theta is equal to secant of 90 minus theta. We have supplementary angles also. I'm not gonna get into more for depth. We don't have much time. I hope it is clear. So now we are gonna derive trigonometric ratios for some standard angles. Consider a triangle as follows. I hope you are making some understanding of it. This is A, this is B, C. This is a triangle ABC. Let's say base is equal to height is equal to A. That is because we are considering the internal angle as 45 degrees. If we consider this angle as 45 degrees, this becomes 90 minus 45. That is just 45. This becomes an isosceles right angular triangle. So these angles, angle A and angle C, are equal. So their corresponding adjacent sides will also be equal in magnitude. AB is equal to BC. Another way, base is equal to height is equal to A. See, now using Pythagorean theorem, we can say AB square plus BC square is equal to AC square. AB square plus BC square is equal to AC square. Right? So A square plus A square is equal to 2A square. So we get AC is equal to root 2A. Using these values, we find the trigonometric ratios. Now sin A is equal to opposite by hypotenuse BC by AC is equal to A by root 2A, 1 by root 2. Similarly, cos is equal to adjacent by hypotenuse HCAB by AC. This is A, this is A, this is root 2A. I have not mentioned here. Mm, and tan is just the ratio of these. It's a sine by cos. So opposite by adjacent, tan is equal to BC by AB. As these two sides are equal, it's just one. And we have other trigonometric ratios, cosecant, secant, and cot, which are just inverses of these. We can get cosecant by taking the inverse of it. I mean the reciprocal of it. It becomes inverse for this ratio. It's just 1 by 1 by root 2, and secant becomes root 2, and cot becomes 1. Now we are gonna derive trigonometric ratios for 0 degrees and 90 degrees. Now you take a figure as follows. You can see it here. Consider this particular triangle ABC. We can observe this angle A. As we decrease this angle A, this height is decreasing, and even the hypotenuse is decreasing, but the base is as it is. The magnitude of base is as it is. You can say the height is decreasing as well as the hypotenuse. As soon as this angle A becomes 0 degrees, height becomes 0, because once the internal angle becomes 0, its opposite angle also becomes 0, and the hypotenuse coincides with the base. So hypotenuse is just embedded into the base. So hypotenuse is equal to base is equal to, let's say, some A, and base is equal to 0, height is 0. Now sine A is equal to opposite by hypotenuse. It's just BC by AC, which is just embedded into it. We can't see it properly here. It's just 0 by A, it's just 0. 0 by any real number is just 0. And cos A is adjacent by hypotenuse. Both are just embedded into this line. A by A is equal to 1. The adjacent side to this angle A is just here, embedded into the this line. A by A is just 1. And tan A is opposite by adjacent, opposite this BC. It's just 0 by a magnitude of this line. 0 by A is equal to 0. And cosecant is just a reciprocal of sine value. I haven't mentioned these angles properly here, but I have mentioned here. This is sine 0, this is cos 0, and this is tan 0. I hope by this diagram it is understandable. Now, if we want to find the cosecant of 0, it's just the reciprocal of this. 1 by 0 is undefined, or some people may say infinite. And the secant is just the reciprocal of this. 1 by 1, 1. And quart is also undefined. Similarly, with the same intuition, let's increase this time. We have decreased last time, now we will increase this. As we increase this angle here, this opposite angle C is decreasing, and this once this angle C is decreasing, its opposite side will also decrease, and this internal angle A is increasing, so its opposite side BC will increase. Oh, sorry, it's not increasing here, it's as it is. um Hypotenuse is also decreasing, you can observe. This height is not changing its magnitude. Hypotenuse is decreasing in magnitude, and base is decreasing. Mm, Soon, this angle A becomes 90 degrees. Then the base becomes 0 in magnitude, and the hypotenuse coincides with height. Now, the magnitude of hypotenuse is equal to the magnitude of height. This is why I said hypotenuse is not always the largest side of a right angle triangle. These two are some exemptions for it. Now, if we want to find the trigonometric ratios for 90 degrees, now we can see here AC is equal to BC is equal to, let's say, some A. This height is embedded, uh, hypotenuse is embedded into height. They both are coincide. Now, sine A is equal to opposite by hypotenuse. It's just BC by EAC. It's just A by A is just 1. Now, cos A is equal to AB by AC. This AB is 0 here. 0 by A is equal to 0. And tan A is opposite by adjacent BC by AB. BC height by AB is 0 here. So a real number divided by 0 is undefined or infinite. And these inverses are the just reciprocals of these values. Cosecant 90 is just 1 by 1 1, and secant 90 is undefined. Yeah, this is undefined, so we cannot do in a reciprocal of this undefined. So we will have to find out this reciprocal of this ratio. It is AB by BC. It's 0 by A, 0. So cot 90 degrees becomes 0. I hope it is clear. If anyone is charting in the chat box.
I think there is somebody raised their hands actually. Shubham sir.
Um, um, I think I'll miss my pace. If someone is trying to talk, you can.
No, I can't see any hands raised right now. Like long before someone raised, but now it's not here.
Okay, after every slide, I will give some time. If I will ask if anyone have any doubts or anything to ask, please go. I can't check it every time. I will miss my pace. Okay. Any doubts so far?
I think we will continue and we can take the question at the end actually. It'll be useful.
Okay. Now we'll find the trigonometric ratios for 60 degrees and 30 degrees. Let's consider an equilateral triangle ABC. As you can see here, now you draw a perpendicular bisector to BC and name it this point, this intersection point as D. Now this AB is equal to BC is equal to AC. As we know, all sides of an equilateral triangle are equal and all internal angles are equal, 60 degrees. Now you draw a perpendicular bisector from A to this side, opposite side. So as it is a perpendicular bisector, these two angles are equal and these two sides are equal. BD is equal to DC. So 60 by 2 is 30 degrees here. Now we have formed two right angle triangles. Using this figure, we'll try to find the trigonometric ratios for 60 degrees and 30 degrees. Now you can consider this each side as A, some A. Then this BD is equal to DC. So BD plus DC is equal to A, and both are equal. So BD is equal to A by 2. And this AD is something we are gonna find using Pythagorean theorem. AC square. Um, I have taken AC square here. Let's consider AB square. AB square is equal to BD square plus AD square. So A square plus A by 2 whole square plus something AD square, right? Sorry, AB square is equal to BD square plus AD square. So A square is equal to A by 2 whole square plus AD square. And using this, some manipulations, we'll take AD square to the left side and we'll do some manipulations and we'll get AD is equal to root 3A by 2. We can put this AD square to the right side and we can take this A square by 4 to the left. That way we get AD square. We take square root on both sides. We get this AD as root 3A by 2. So using these results, that BD is equal to A by 2, AD is equal to root 3A by 2, and AB is equal to A, and we are also known with the internal angles. We will try to find the ratios. Now sine 60 is equal to this opposite one. Here is AB. I have taken AC. Oh, no problem. Okay. Now sine 60 is equal to opposite by hypotenuse, which is AD by AB. Root 3A by 2 by A. See, both A will cancel and it is root 3A root 3 by 2. And cos 60 is adjacent by hypotenuse. It is BD by AB, A by 2 by A, it's 1 by 2. And tan 60 is just the ratios of this. It is adjacent by opposite. Oh, sorry, it is opposite by adjacent. Tan 60 is equal to opposite side to this angle 60 divided by its adjacent side. Tan 60 is equal to AD by BD, root 3 A by 2 by A by 2. Both A by 2's cancel and it is root 3 by root 3. And if we want to find the cosecant of 60, it is just the reciprocal of it. It's 2 by root 3 and secant of 60 is 2, the reciprocal of this. And cot 60 is 1 by root 3, the reciprocal of this value. Now, similarly, with the same idea, we will find the trigonometric ratios for 30 degrees. Now, sine 30 is equal to opposite by hypotenuse, it is BD. This is 30, right? Now we are considering angle A. Now opposite by hypotenuse BD by AB. This is A by 2 and this is A. So we get 1 by 2 and cos 30 is adjacent by hypotenuse AD by AB. It's root 3 by 2. Tan 30 is BD by AD. Opposite by adjacent. A by 2 by root 3 A by 2. We get 1 by root 3. And if we want find the cosecant of 30, it's just the reciprocal of this value. It's 2 and secant of 30 is reciprocal of this value 2 by root 3 and cot 30 is reciprocal of this value, it's root 3. I hope this derivation and explanation is clear. Any doubts? Okay, this way we can form this standard ratios table. We have angle on these columns and ratios uh, on these rows. Okay. Now sine 0 is 0, cos 0 is 1, tan 0 is 0, cosecant of 0 is undefined, secant of 0 is 1, cot 0 is not defined, sin 30 1 by 2, cos 30 is root 3 by 2, tan 30 is root 3 by 3. It's just 1 by root 3. We can multiply root 3 on both numerator and denominator. And these are just reciprocals of this. Sin 45 is 1 by root 2. Cos 45 is 1 by root 2. For my convenience, I consider as 1 by root 2. We just multiply with root 2 on both numerator and denominator. And sin 60 is root 3 by 2, cos 60 is 1 by 2, tan 60 is root 3, and these values are reciprocals of these. Now sin 90 is 1, cos 90 is 0, tan 90 is undefined. And note that we cannot take a reciprocal of an undefined value. If we want to find the cot, cot 90, and if we are known with tan 90, we cannot take the reciprocal of undefined value. In that case, we will have to go with the derivation if you want to find out, or we can just remember this. Okay, any doubts? Mm, Now we have trigonometric identities. Sin theta is equal to altitude by hypotenuse, cos theta is equal to base by hypotenuse, tan theta is equal to altitude by base. Consider this altitude as A, hypotenuse C, and base B. Now, using Pythagorean theorem, we know that a square plus b square is equal to c square. Now we divide with c square on both sides. We get a square plus by c square plus b square by c square is equal to 1. Now we can see here a by c is just sine theta. So sine theta will be substituted here, and b by c is cos theta. Cos theta substitute here. So sine square theta plus cos square theta is equal to 1. Similarly, now this time we'll divide with a square on both sides, and we will take this b square to the right side. In that way, we'll get this one. C square by a square minus b square by a square is equal to 1. And c by a is just the inverse, of the reciprocal of this value. So it is the inverse of this sine theta. C by B. Oh, sorry, this is a mistake. C by A is cosecant theta. This is a mistake. It is cosecant square theta minus cot square theta is equal to 1. And this is secant square theta minus tan square theta is equal to 1. No, this is wrong. This is C by A is the reciprocal of this value, the inverse of sine theta. It is cosecant theta. Cosecant square theta minus cot square theta is equal to 1. That is how we get this one. And C by B is the inverse of this cos theta. It's secant square theta minus cot square theta. Yeah, baby, the reciprocal of this. And these are some other trigonometric identities. As we know, cosecant theta is the inverse of sine theta, and secant theta is the inverse of cos theta, cot theta is the inverse of tan theta. That way we get these identities. Sine theta into cos theta, cosecant theta is equal to 1, cos theta into secant theta is equal to 1, tan theta into cot theta is equal to 1. We have more time. Hello.
Yeah, yeah, you have 5 minutes more, 5 to 7 minutes.
Okay, okay. So I'm almost done with my presentation. We have some real world applications of trigonometry. Trigonometry is vital in various fields, including physics, engineering, architecture, computer graphics. In civil engineering, it's most vital. It's handy. In physics, we usually know it is used to find forces. And in computer graphics, in game development also it is used trigonometry, and in modeling periodic phenomena, and in some designing structures, and in astronomy most importantly. Trigonometry is the most useful and most applicable one. Um, this is it.
Thank you,
Thank-
Kiran. So, if you are done, can we move on to the question and answer session?
yeah, I'm done.
Okay, so for the questions, please raise your hands, and we'll refer to the questions one by one.
Any doubts?
We'll wait for some time. If anyone has any question, please raise your hands. So there is a question in the chat box. Which part of trigonometry do you find fascinating?
Yeah, I find the aptitude solving geometric equations. I find that very interesting.
Yeah, Pranav, you can unmute yourself to ask the question.
Mr. Kiran, may I call you Mr. Kiran? Oh,
I'm
okay.
unmarried.
Okay. Okay. Anyway, so actually, do you have any sources to read? Actually, may I ask that what sources do you read in trigonometry? Like, where do you
Uh,
find?
uh, no, no, no. I didn't refer any source. Frankly, I have made my own content. I use this matcha for editing. It's
Okay.
very difficult, so that's why I found one or two mistakes.
Oh, okay.
Uh, it's very difficult to do max editing in PPT.
Yeah,
If I
definitely.
Yeah, I mean, say if I can speak over there, you see, apart from what has been presented in this case, if you want to take up trigonometry, like in a sense of a bit of, I mean, say, find it more kind of entertaining or fascinating, for example, there are some very interesting topics which are present in a particular book. There is a book by Ellie Meyer, actually, and the name is Trigonometric Delights, actually, right? Historically, trigonometry has been taken as a subject which is kind of boring, at least in school. That is how it's being projected, actually. However, Ellie Meyer has actually collected a few very nice anecdotes regarding uh, trigonometry and its applications, actually. The book name is something called Trigonometric Delights, actually, right? You can find the PDF already in online form. And it actually contains a lot of interesting features from history and some very interesting applications. Application, for example, like map making, okay? Map making is one thing where kind of, projecting a spherical earth right onto a page, a paper, actually, a flat plane. And that something was used by something called Mercator's projection, actually. Mercator projection is one thing which is application of trigonometry. If you get some time, you can just look at it. Otherwise, apart from, if you just want to kind of refresh your memory and have the very basics of trigonometry, there's a very good book, trigonometric, just trigonometry, by the way. The author name is S.L. Loney, actually. If you could refer to that, it's a very interesting, good book, actually. You can consider almost like a Bible for trigonometry over there, right? That's from my side of. Okay. Yes, Atriya.
Yeah, Atreya.
What is the objective of this session? Trigonometry. If we know all the basics of trigonometry, then
So okay, Atreya. So this session is actually we keep it as recapping or recalling your trigonometry concept. So and purposely this presentation is not only for recalling. This is for enhancing this presentation skill. So this platform is actually giving an opportunity to enhance or skill up yourself in as a presentation form. So Kiran is the first student of us of BS degree. He is actually very much interested and to present to in front to all of our BS degree student. And also so he actually wants to not only whatever the thing he thought maybe is find it interesting, so that's why he chooses this topic. And also he wants as of now, no. So he wants to skill up his as a presentation form. So, and this is the best place form I will say to scale up in at least in a presentation form.
I think
That is the purpose.
Kiran can switch on the presentation. Sharing.
Okay.
Guys, I've shared the feedback form in the Google chat and I've pinned it. So please fill the feedback form. It would be really helpful for us to understand what's your reaction upon this session.
Yes, so yeah, this is a request. So please fill out this feedback form so that we know how people are getting taking it. Is this truthful? So this actually this basics of trigonometry is, I thought, maybe as in the qualifier, many of or maybe I have seen in ES is trigonometry, but in diploma science there is no trigonometry taught by professor. So I thought this may be fruitful for the foundational student. So maybe this recalling, recapping this trigonometry. Okay, so give us the feedback so that we will improve ourselves as a big platform, a pi square. Generally, in here in mathematics department, we have no a curriculum seminar kind of things is happening. So we are actually bringing such idea here in the BS degree also, so that the people will present whatever they have, and also the share your knowledge to all of BS degree student. So this is for mathematics only. We'll see it later how the for other courses also may be there. I'm not sure, but this could be. So this is a great form. This is the purpose of this pi square seminar series.
So is there any other question for Kiran?
Yes, this is not exactly related to this because I joined very late due to certain restrictions. So, is there any video available, recording available afterwards? Will there be, or it's not?
Yeah, we recorded the session. I think it will be available over YouTube.
Yeah,
All
so
right,
we'll try to be, we'll upload on YouTube and will be shared to you, to all of you.
sure.
Maybe you
Okay.
can create
Thank
a
you.
YouTube page for this, sir.
Yeah.
Okay, sure. Thank you.
So any other questions? Okay,
Doing
so
so.
I think no more questions. So thank you everyone for joining. And if you are really interested by this in giving a talk to this session, we will roll out Google Forms. So please do fill it and do give us your topics which you want to talk about and share with your peers. We would be very happy to have a great and healthy learning experience. Thank you so much. Thank you everyone for joining.
One interruption. Sorry.
Yeah, yes.
In yeah, in case suppose I'm not 100% comfortable with one topic, but still I know certain up to a certain extent. Let's say 70%. Still, in that case, is it a good idea to present, or
Yeah,
Yeah,
sure.
sure. We will help you with that. Like we have a technical team. We have a technical team with the PySquare seminars. So once you come up with your topics of interest which you want to share, we will enrich you with more materials about which you can talk. It would be a learning experience for you as well as for the others as well. So like
sure?
we have that thing. Like Shubham sir is there, Anant is there. I'm also in the technical team, so we will really help you to get enriched in the topic as well. We will try to cover that 30% so that you can give your 100% in the actual talk.
Exactly. Wonderful. Thank you
Everything
very
is
much.
Yeah.
very much welcomed over here. It's
Thank you.
it's
Thanks
it
a lot.
should be a healthy learning platform. That's our initiative. It should be a healthy learning platform from peer to peer.
All right. All right. Thank you. Thanks a lot.
Yeah. Thank you.
Hello, is there any feedback or anything
Uh,
improve? This is my first
that
one.
you will be knowing after the session. I think after the
Uh,
session
I,
is over. complete, then we will let you know the feedbacks for sure.
And yeah, actually, it's asking also that anyone want to give any improvement suggested to Kiran. That is also a good thing. He will know that okay, that is the thing he wants to improve. He should to improve. So, do you want to say something on this Kiran presentation?
Well, there's only one thing that I would like to say, by the way. There's, first of all, be specific about the words. Here, you have been using the word inverse multiple times. Technically, it should have been the reciprocal, actually. The inverse is something
Yeah.
which is a bit different, right? That's
Yes.
one thing that we have. Apart from
It's
that,
a
everything else, I
reciprocal of
think,
the value.
Sir, also,
Only the inverse
also,
of the ratio.
also he just miscoined the terms. Actually, I'm pretty sure that he knows it, but he miscoined the terms as infinity and undefined, so that was a bit of
Yes.
technical error. So you should be very careful about the words which you coin in the thing, because it's a science, and science is very specific about its
exactly.
words to be coined in
And
language.
especially maths, by the way.
Different people talk about it differently. Some people say not defined, undefined, infinite.
Undefined is the correct word, by the way, but you
Yeah.
do not have infinity in this case because you cannot divide by zero. So undefined is the correct word to use, not infinity, actually.
Actually, if you go back a bit to your high school, what we were taught about fractions, then if you remember that pie chart wala picture which we were taught, then what we do in fraction actually is of from an entire pie chart we just cut out a part of it. So zero is nothing, zero is null. So how can you cut out a part from something which is not there? So like you cannot define it, right?
That
So,
is
so
interpretation,
that's
definitely.
that's I think a very intuitive definition of undefined, and infinity is a comparative quantity after all. So
Yeah.
that's how you can imagine it to be.
Okay, can I ask one question?
Yeah,
Yes.
sure.
Yes, Umar.
Yeah, I'm asking, like, I was late to this. I'm sorry for that, but what are the things that we can contribute in this? Like, apart from maths, any other thing is there, or only maths is there?
So here we are very specific, but still we are thinking to in the stat part also. So even the data science part, even we will try to include. So like MLF, MLT. So let's see that like what topics you want to and what like
Maybe
get
like
there.
maybe coding or something like Python or any other language, because that's the thing I like. Maybe I can, but not sure.
Yeah, but yeah, it's good actually. Okay, so uh, coding a Python, okay? Python is that you are saying, or maybe different also.
Yeah, maybe Java
Uh,
or Ruby or Kotlin, any other language, or maybe uh, any other language, or maybe any other thing which I made and I want to maybe show how I made something like that. A few days ago, I kind of made something. That's what.
yeah, it would. I will say, yeah, it would be welcome. So try to send us. We'll see it, and we'll try to enrich with our core team with the different area also, so that presentation, this kind of seminar, this presentation would be good.
Okay, thank you.
Even not only for very specific on mathematics, we'll try to enrich. So if you have, please share with us. We'll enrich the core team with different area.
Okay, if like the project is related to maths only, like for example, I think so. I made few years ago a project in Java that can do like for mathematics. Like for example, you can do algebra in
Yeah,
it. You can also do
it's
trigonometry
very,
in it.
then it will be very good. Yeah, people actually want. So here student want, they want to see how it could be include the mathematics
Yeah,
in this
yeah.
Python or yeah.
I'm really interested in that. That's like the thing which I want to show and I want to learn also a lot.
So
Okay, thank
most
you, sir.
welcome. Yeah, most welcome, Anwar.
Okay, thank you, sir.
Yeah. So I hope you. I have. Let me share you the G form also. Just a second. So that if people want to connect us, they can feel this G form, and so that I will know that these are the they wants to be here. So this is the G form who wants to be connect with us as a presenter, as a part of. So this is one thing I want to tell, that not only this provides you the chance, also you will get a chance to get certificate from this ITM PS. So the all presenter will get a certificate that he have presented in this on this platform. Okay.
Just one second.
Yeah.
So is this arranged by code?
No, this is not from the code. This is arranged from maths team only. This is not from the code. Yeah, and anybody have chooses some topic can change any at once you start creating slide, till that time you can change even the topic. I will say you want to change that topic, you can change. There is no issue with that.
So thank you everyone. And any other queries? So
Okay.
I think, sir, so should we wrap up the session?
Yes. Yeah, thanks everyone for joining. I want to keep more thank on Kiran. He's actually get courage and presented the first seminar. Thanks you so much, Kiran, and others. Thanks for joining even, and our thank you so much for the core team members. Actually help a lot to Kiran and for me also, so that we'll be here. Thank you so much.
Thank
Yes,
you.
so
Thank
someone
you.
wanted the YouTube link to the session. I think it will be uploaded.
Yeah, once it will be uploaded, I will try to send an announcement. Maybe what we can do, once the next session would be there, next presentation, below that the YouTube link of the previous one will be shared to all. That's how it will go, I think.
Okay.
Thank
Okay.
you, sir. Thank you for the opportunity.
Yeah, thanks. Okay.
Thank you everyone for joining. Thank you so
Thank
much.
you.
Good night. Bye to all.
Thank you. Yeah. Right.
Yeah, bye everyone. Thank you, sir.
Bye. Thank you.